Hi students, this is Alex here. In this video, we are going to find the half-range Fourier sine series for the given function f of x. As a first part, we are going to write the formula f of x equal to summation n equal to 1 to infinity bn sine n pi x by L, but here L is 1. And the formula for bn is 2 by L integral 0 to L f of x into sine n pi x by L dx. After replacing L as 1, we get 2 integral 0 to 1 f of x into sine n pi x dx. We are going to substitute f of x, but f of x is made up of 1 by 4 minus x for this interval 0 to half and x minus 3 by 4 in the interval half to 1. So we're going to write it as two part. One is 2 integral 0 to half, and 0 to half our function is 1 by 4 minus x into sine n pi x dx, and second part again 2 integral half to 1, and this time our function is x minus 3 by 4. So x minus 3 by 4 into sine n pi x dx. We are going to use Bernoulli's formula. So first part is u, second part is v. So u equal to 1 by 4 minus x and v equal to sine n pi x, and u dash is minus 1 and u double dash is 0. v1 is integration of sine is minus cos n pi x by n pi, and v2 is minus sine n pi x by n pi whole square. In the same way, here this is u and this is v1, v. So u equal to x minus 3 by 4 and v equal to sine n pi x. U dash will be 1 and u double dash will be 0. Here v1 is minus cos n pi x by n pi, and v2 is minus sine n pi x by n pi whole square. And the Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So now coming to bn equal to 2 bracket open u, which is 1 by 4 minus x into v1, which is sine n pi x minus u dash is minus 1, so we can make this as plus, and v2, sorry, here we have to substitute v1, so let's correct it. So v1 is here minus cos n pi x by n pi minus u dash is minus 1, so minus we make it as plus, and v2 is minus sine n pi x by n pi whole square, and our limit is from 0 to half. In the same way, here second part 2 times of uv1, so x minus 3 by 4 into minus cos n pi x by n pi, then minus u dash, so minus 1 into v2, which is minus sine n pi x by n pi whole square, and limit is from half till 1, and u double dash is 0, so we stopped it till 2 terms. Now applying the upper limit, so bn will become, when we apply the upper limit, 1 by 2 for x, so this will become 1 by 4 minus 1 by 2 into minus cos n pi by 2 by n pi. Then when I apply for this, we get minus sine n pi by 2 by n pi whole square. When we use the lower limit, we get minus of 1 by 4 minus 0, and cos 0 is 1. So there is a minus sign. So minus 1 by n pi. And the last term we have sine. So sine 0 is 0. And first part we completed. Now plus, coming to the second part, we have to substitute 1. So 1 minus 3 by 4. And this is minus 1 into. When I substitute here 1, we get cos n pi. Cos n pi is minus 1 whole power n by n pi. Then here we can make this as plus because we have two negative sign. So I can make this as plus. When I put 1 here, we get sin n pi, which is 0. And coming to the lower limit, when I put 1 by 2, this is 1 by 2 minus 3 by 4 into minus cos n pi by 2 by n pi and plus sin n pi by 2 by n pi whole square. So we completed substitution of limits. Now further simplification, we have 2. This part is 1 by 4 minus 1 by 2 is minus 1 by 4 into minus cos n pi by 2 by n pi. And this one as it is minus sin n pi by 2 by n pi whole square. And here this minus and this we can cancel and make it as plus. So we left with plus 1 by 4 n pi. Then coming to the second terms, but here one thing, when we apply the lower limit, we have to change the sign. So here when we apply the lower limit, it will be minus. So here I take the minus. Sorry, actually it was minus, so we cancelled and we made it as plus. It's right. Now coming to the next set of terms, we have 2. 1 minus 3 by 4 is 1 by 4, and this is minus. We can keep the minus here. Then minus 1 whole power n by n pi. And now minus, if I take LCM here, I have to multiply this into 2 and into 2, so that I get 4 as the common denominator. So 2 minus 3 is minus 1 by 4 into minus cos n pi by 2 by n pi. And again we have, let's not close this bracket because we have plus sin n pi by 2 by n pi whole square. So further simplifying this, we are going to get bn as 2, and we can cancel these two. So this is cos n pi by 2 by 4n pi minus sin n pi by 2 by n pi whole square, then plus 1 by 4n pi. And we can take this 2 common, so plus, we have minus 1 by 4, so I directly take minus 1 by 4 n pi, and in the numerator we have minus 1 whole power n. These two I can cancel, but there is a minus sign, I can take it inside. So minus cos n pi by 2 by 4n pi, and again minus sin n pi by 2 by n pi whole square. So here we can cancel cos n pi by 2 by 4n pi minus cos n pi by 2 by 4n pi. So same term with opposite sign, we cancelled it. So bn will be 2 times of, we can combine these two terms. So it is minus 2 sin n pi by 2 by n pi whole square. Then we can write this one, which is minus 1 whole power n by 4n pi, then plus 1 by 4n pi. Actually, we can take 1 by 4n pi common as a common denominator. We can write this 1 first, then minus of minus 1 whole power n. Then this term minus 2 sine n pi by 2 by n pi whole square. So we have bn like this. This is our bn, but this we can further take like two conditions like even and odd. Suppose if n is odd like 1, 3, 5 dot dot dot, then what will happen to bn is, if I take a odd number, that is 1 minus of minus 1 whole power 3. So 1 minus this becomes minus 1, and this will become totally 1 plus 1, which is 2. So I get 2 by 4n pi. So this will become 2 by 4n pi, and when I take odd multiples of n here, it will come like alternate sign plus minus. So it is better to write this term as it is by n pi whole square. Now this 2 I will multiply inside, so it will become 4 by 4n pi minus 4 sine n pi by 2 by n square pi square. So finally this is, after cancelling, we get 1 by n pi. So 1 by n pi minus 4 sine n pi by 2 by n square pi square. This is bn when n is odd. If it is even, suppose if n is equal to 2, 4, 6 dot dot dot, then 1 minus of minus 1 whole power n will become 1 minus of minus 1 power 2. So 1 minus 1, it becomes 0. In the same way, sine n pi by 2, when I put a even number 2, we get sine pi. When I get sine n pi by 2, when I put 4, I get sine 2 pi. So every term will become 0. So bn will be totally 0. So therefore, bn we have it as 1 by n pi minus 4 sine n pi by 2 by n square pi square when n is odd, and it is 0 when n is even. So these are the value of bn. We have it now. So using this in our f of x formula, we have f of x equal to summation n is equal to, now I have to write only odd till infinity. bn is 1 by n pi minus 4 sine n pi by 2 by n square pi square whole thing into sine n pi x. To convert this odd till infinity as 1 to infinity, we can replace n as 2n minus 1. So this will become summation n is equal to 1 to infinity 1 by, wherever n is there, it is replaced as 2n minus 1. So 2n minus 1 pi, and even here minus 4 sine 2n minus 1 pi by 2, then whole divided by 2n minus 1 whole square pi square, then whole bracket into sine n pi x is sine 2n minus 1 pi x. So this is the required half range sine series expansion for the given function f of x.